Hello everyone, my name is Pritham Kumar, and in this video I'll explain my practicum number 13 of Computer Organization and Architecture, which is titled as GPU execution using NVIDIA Jetson Nano. So it is about GPU execution on Jetson Nano. We'll be comparing CPU execution using NumPy and GPU execution using CUPy, and we'll see how parallel processing improves performance. So coming to the concept, CPU works like a single worker doing tasks one by one. GPU works like thousands of workers doing tasks together. So for large data, GPU becomes much faster. First, I'll be explaining the Python code. So here we are importing NumPy, which is used for CPU computation. And this try and except blocks, this checks if GPU is available. Here we create large input arrays. CPU performs vector addition and we measure time. In this if statement, data is transferred from CPU to GPU memory, and here the GPU performs parallel computation. So we'll run it. GPU is faster for large data because it performs operations in parallel. CPU is sequential, but small input not show big difference. So that's why it's showing us error. Second problem is about performance versus input size. Here the different input sizes are tested, and here we can run loop for each size. And C equals to A plus B is CPU execution, and here it is GPU execution. I will run it. This list shows that CPU time increases steadily while GPU time grows slowly. So GPU advantage increases with larger data. Parallel processing becomes more effective as data size increases. Coming to the third program, it is about data transfer overhead. This line transfers data from CPU to GPU, and this transfers data from GPU to CPU. And everything is almost the same. We will run it. You can see this transfer takes time. So if data is small, transfer time is greater than the computation time. That's why the GPU is not always faster. GPU is powerful, but data transfer is hidden cost. Now let's go with the MATLAB code. First program, vector addition, CPU versus GPU. This line allows MATLAB to try working with newer GPUs, even if not fully matched. And n equals 1e6 is the vector size, which is 10 lakhs, and a equals to random of n comma 1 is the random vector from A. B equals rand n comma 1 is the random vector B. And TIC is a start timer, and C underscore CPU is equals to A plus B is a normal addition, and TOC is to stop the timer. CPU works sequentially, one step at a time. And the GPU array moves A to GPU memory, and GPU array B moves B to GPU. C GPU equals to A GPU plus B GPU. This line indicates the GPU does parallel addition, and the wait GPU device ensures GPU finishes before measuring time. Try catch block indicates if the GPU is not working, it needs to fall back to CPU. So the key area is CPU equals to one chef cooking and GPU equals to 1000 chefs cooking simultaneously. We'll run it. You can see the CPU and GPU times here. The second program is about performance versus input size. Here we're testing this on large data. These two lines are used to store the execution time, and this for loop runs experiment multiple times, and this line stores CPU time for each size. This line stores GPU time. This para is for the graph which shows comparison visually. Let's run it. You can see the graph over here. Small data is CPU similar to GPU. Large data is a GPU dominance over CPU. In the left, we can see the list of size and CPU time and GPU time. GPU needs time to transfer the data first. Startup cost. The third program is about CPU to GPU data transfer. This line sends data to GPU memory. This brings the data back to CPU. T1 is uploading time and T2 is the downloading time. The real meaning is that think of a GPU like a remote supercomputer island. Sending data takes time. Processing is super fast. Getting the result back, again, it takes time. We'll run it. You can see the CPU to GPU transfer time is actually lesser than GPU to CPU transfer time. Final understanding is the CPU sequential processing. GPU is parallel processing. GPU array moves data to the GPU. Gather brings data back. Tick and talk, it measures time. And the try catch block handles errors safely. GPU performs parallel computation using multiple cores, making it efficient for large datasets. Why CPU is faster? Due to the data transfer overhead between CPU and GPU. Thank you.